And the second example of single flow graph using Mason-Gaine formula. The first step, we'll see the number of forward path. Here the number of forward path is 1. It is a feedback path. It is a feedback path. It is a feedback path. Feedback path. Therefore, there has a number of forward path is 1. The forward path is 1 to 6. The only one forward path. The forward path is 1 to 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. G1 and G2 and G3. It is a forward path. Therefore, path gain or forward path gain P1 is equal to G1, G2, G3, the product of three functions. Second step, we'll see the number of loops. Here the number of single loops are 3. The number of single loops are 3. The loops are here the one loop, it is here the one loops, and here the one loops. The loop start from 2 to 5 and again end to 2. It is a loop. There has a 3 loop. 1, 2, 3. Loop on 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. The loop 3 to 4 and 4 to 5 again output to input the feedback path. The one loop, the feedback element is minus h2, the other function g2, g3. Therefore loop gain L1 is equal to the product of transfer function g2, g3, h2. Loop 2 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Loop 2 to 3, 3, 4. 4 is committed to the node 2. The transfer function G1, G2, G1, G2, feedback element H1. Therefore loop gain L2 is equal to minus G1 G2 to H1 G1 G2 H1 here product. Last loop 3 loop 3 3 4 5 6 1 2 3 4 5 6 2 3 3 to 4 and 3 to 5. Feedback path is connected to the node 2. The feedback element is minus H3 G1 G2 G3. Type loop gain L3 is equal to G minus G1 G2 G3 into H3. Here the number of two or more than two non-touching loops are 0. Here the no non-touching loops. Here the number of two and more than the non-touching loops are 0. The loops are touching to each other. Here the three loops 1, loops 2 and loops 3, the three loops are touching to each other. Because to each other there has a no non-touching loop. Then the Mason gain formula. The Mason's gain formula T within bracket S is equal to 1 by del summation of P suffix K into del K. The del is equal to 1 minus the del is equal to the determination of the gain. Thus, here I have put the sum of individual loop gain. Sum of individual loop gain. Here the loop gain are 3. The 3 loops 1, loops 2 and loops 3. And their sum of individual loop gain. The loop gain L1 is equal to G0 minus G2, G3, G4. Sorry, G2, G3 and H2 and loop 2 here and loop 3 here. In the 3 loop gain I have the sum of individual loop gain. The sum of individual loop gain is one is minus G2 G3 H2 minus G1 G2 H1 minus G1 G2 G1 G2 G3 H3. Here the 1 plus G2 G3 H2 plus G1 G2 H1 plus G1 G2 G3 H3. Number of forward path del 1 is equal to 1 minus 0 is equal to 1. Here the number of forward path is 1. The forward path, it is the number of forward path 1 is equal to P1 is equal to G1 G2 and G3. Therefore the transfer function T bracket S is equal to, I have put here the value of forward path. The value of the forward path P1 is equal to G1 G2 G3. G1 G2 G3. Here I put the value of del 1 plus G2 G3 H2 plus G1 G2 H1 plus G1 G2 G3 H3. This is the transfer function of single signal flow graph.